Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome once again, Distributed Data Show. I'm Jeff Carpenter, and I'm here in the studio today with Luke Tillman.
Hello, everyone.
So I don't know what everyone thinks an evangelist does, but it turns out that we actually have real developer chops. We're real people, real developers, real software engineers and architects too. And we happen to do a lot of fun stuff to promote things that we love and talk about things that we love. But, you know, we're developers and technologists at heart. So I want to talk to Luke a little bit about what you've been doing lately, because I would consider you, maybe term is overused and overbaked a little bit, but a full stack developer. Would you own that? Would you own that or not?
Yeah, you know, it's funny. I saw a tweet this morning. Somebody said my favorite part of looking through a code base where a full stack developer has worked on it is figuring out which part of the stack they didn't know, which is totally true. Like it's. I mean, yeah, I know enough to be dangerous, I think. It's probably true.
Legit. I think that you're a legit full stack developer in maybe the proper sense of the word. I'll give you the credit for that. So I want to hear about your latest project that you're working on.
Okay. So just don't call me a 10x developer like that.
Oh,
that term,
no way. Yeah.
That term drives me crazy. So I'm a technical evangelist, right? I've been with DataStax now for going on 4 years. And, originally, one of the original projects that I worked on when I started at DataStax was Killer Video, which was our reference application that now you and David Gilardi have kind of taken over stewardship of.
We haven't screwed it up yet.
Yeah, hopefully you don't screw that up. But so for me as an evangelist, one thing that's really important is getting my hands on technology, and I just love writing code, and so to me it's like I always want to have a project. I always want to have something where I'm writing code or doing something, and so I kind of had an opportunity where our Academy site, DSA for short, so DataStax Academy. This is academy.datastax.com.
There you go.
Like shameless plug. So we had this project where we wanted to kind of do some more dog fooding of our own, our being DataStax's own product. So we wanted to start building more parts of the Academy site that people go and learn on top of DataStax Enterprise.
So we actually have a cloud scale data problem.
Right. We do.
Justifiable usage of our own product. I love it.
Yeah. So what we were, so the problem in particular that we were kind of trying to solve was people are, as people come on to DataStax Academy and they take courses, and those courses have units in them, and they kind of like make progress as they go along through those courses. We want to record, how far along are you in the course? Where did you leave off?
Right.
And you can imagine that, we have, not a huge number of courses right now, but a good amount of free content up there. And, if you break it down to the unit level, we've got even more inside of each of those courses. And then you multiply that by all the number of users that we have, which we do have quite a few users on DataStax Academy. And what we had this table where we were storing all of this progress information on who's made progress and when they made it and where are they and stuff like that.
Well, you're easily talking millions of data points.
Growing,
right?
And as the number of courses continue to grow and as the number of users continue to grow, we could kind of see this table that was in MySQL starting to creak a little bit. And so it's kind of like the classic. It's funny, it's kind of like the classic problem of how do we take and distribute this across this amount of data across more than one machine. So
hey, I know how to solve that problem.
yeah. And so it was it's kind of a cool thing. Like we're standing up as part of this project, it's kind of not only starting to move some of our DataStax Academy data onto DataStax Enterprise, but we're also this is all going to be in AWS, so we're going to be a DMC, aka
whoa.
yeah, not to use an acronym.
Spell your acronym.
Yeah, spell it out. So DataStax Managed Cloud. So we're going to be a DataStax Managed Cloud customer, like an internal customer, basically. Yeah. So they're going to go ahead and run our DSE cluster for us. But it was also kind of an opportunity to stand up an entirely new stack. So behind the scenes, we're actually standing up, even though most of DataStax Academy has historically been a PHP sort of Drupal-based system, like it's typical sort of
like many apps that are
out
there.
Like a lot of content management. Like you can get really far with a content management system like Drupal or WordPress. So we're standing up an entirely new stack for some of this, with where we're doing primarily most of the development in Node.js, because it's an easy language for a lot of people to sort of pick up, and a lot of people on the team already kind of have that language, those language skills. So
right. Okay. So you pick this new technology stack. What about architecturally? Are you on the microservices bandwagon?
Yes. So everybody's on the microservices bandwagon these days. So yeah, we're trying to do a microservices architecture behind the scenes, sort of do a modern architecture. We haven't. I feel like microservices is almost like passe at this point. Like we're like people are starting to move on to serverless and functions as a service, and
I see. Right.
Well, it's almost like Pico services. Or
maybe we better start talking about something else then. So, but no, I jest. So I've done a microservices architecture myself on a past life. So I know a little bit of the ins and outs and some of the temptations, especially if you're starting with, everyone talks about, hey, carving up a monolith and carving off microservices and using strangler pattern to kind of carve off little bits at a time, and start with your lowest risk services. And a lot of us have probably heard that sort of methodology. Okay, but I've done this and you're doing this too, where you're actually starting from scratch with microservices. What are the perils and pitfalls?
So we could do a whole show about the perils and pitfalls, probably, of once you take a system and just distribute it, and like put the network in the middle, like holy crap. But so one thing that is definitely a challenge once you go to microservices, and I think this is something that people run into quite a bit, is observability, right? So observability becomes super important once you've taken something that was kind of a single thing running in process, sort of the monolith kind of thing, and you start breaking it out across multiple processes distributed around a network. You start to run into the problem of, for example, if a call is slow, how do I know what was slow in that call? Like once things are fanning out to all these to all these different microservices, how do I keep track of what's going on in my system? How do I know what's going on in my system? And so this is where the idea of distributed tracing has become super popular over the last few years.
Gotcha. Okay. Excellent. So what do you mean by distributed tracing? Unpack that a little bit, and maybe, what problem are you trying to solve by introducing distributed tracing?
Yeah. So maybe it's good to start with maybe kind of a description of what does the, kind of the architecture of the thing that I've been building look like. And so
if we have to.
Yeah.
I love hearing about people's architectures.
Yeah. So like just briefly, kind of what we have is React components on the front end. So we're still having to integrate this with the existing DataStax Academy site. And so, we've got these sort of smaller React components that we can embed in different parts of the existing sort of Drupal site. And those React components on the front end, they are talking to an API, like running on a web server, that's actually talking GraphQL. So I don't know if anybody's ever gone and investigated GraphQL, but this is a project from Facebook, kind of cool way of doing APIs, especially when you're using your front end to talk to some sort of back end. So we've got this GraphQL API. GitHub actually just released a giant GraphQL API for all of their developer APIs.
Nice.
So I've seen some adoption out there. And this this GraphQL API then it takes, and as people request different parts of our graph, sort of our graph of things that the front end might need access to, like courses and units and users and all of these things, those calls then get translated by the GraphQL API on a web server somewhere they kind of fan out to microservices on the back end. And so Originally we were using gRPC, and this could be REST APIs, on the back end. You could be using whatever you want for your microservices that are running on the back end. And so the GraphQL API is basically kind of just acting as an API gateway that fans out to these various microservices. And so the problem you're trying to solve with distributed tracing is, you got this call that starts on the client in the browser, for example, with these React components. It goes to this GraphQL server, this GraphQL API server, that's a web server, and then that may fan out to 2 or 3 or 10 or who knows how many.
However many microservice calls.
Yeah. So how do you know, first of all, how many microservice calls are happening as a result of your front end, calling the back end? How do I get some observability into, wow, did I really write some super inefficient, I'm making tons of calls that I shouldn't be. This is kind of like ORMs when you used to have the select n+1 problem, where an ORM would generate like a SQL query it would generate 50 SQL queries kind of thing. So you want to know, am I generating like 50 microservices calls from one sort of call from the front end? And then how do I know if it's slow? How do I know where was it slow? Was it a particular service? Was it that service, for example, talking to a database? Was that service talking to some external service? How do you figure that out? So observability still is the problem that you're trying to solve.
Okay. So what were your technology choices that you made there, and how does this all work together?
Right. So there's a number of kind of things out there right now, and what I ended up sort of settling on for the time being, and maybe at the end we can talk a little bit more about some other options, but what I ended up doing was Zipkin. So Zipkin is a pretty popular open source project that is for doing distributed tracing. I think it's based on Google's Dapper paper, maybe.
Yep.
So basically, you have this framework. It has it has plugins and code available essentially for multiple languages. And sort of conceptually, the idea, it's pretty simple. Most developers, if they were to take a look at this, would probably get it right away. That what we want to do is, when our client makes a call, we want to start with some sort of tracing ID, like some sort of unique identifier. So you could think, if you're familiar with Cassandra, you might think of this as a UUID kind of scenario, where I've got some sort of unique ID for a call that starts on the client. And then when that call reaches my web server, so in my case it was a GraphQL API server, I have some way to basically pull that tracing ID out that was created, at the client, and then I want to propagate that, make sure that tracing ID gets propagated to all of the all of the child calls so all the other communication that goes on, whether it's HTTP calls to other microservices, or it's those microservices then making calls to their databases over TCP connections or whatever it is they use. Basically, I want to keep track of how long, first of all, each of those calls takes, but then I also want to make sure that it's all that all of those calls are sort of tied together by a single tracing ID, so I can sort of see the anatomy, how many calls were made to other services, and be able to correlate it all back to a single sort of client request that kicked it off.
Okay,
if that makes sense.
Gotcha. So is there sort of an expansion factor there? You've got that one client call that initiated everything, and then does that expand out into other IDs below that?
Yes. So the idea, at least in Zipkin, the sort of the data model, or sort of the nomenclature they use, is they call these spans. Okay. So you have one root span, which basically spans the entire duration, starting on the client, from the time the client makes the request, so our React component, all the way until the client receives a response. So it got a response back from the GraphQL API server. But then underneath that sort of root span, you might have a bunch of child spans, which are your calls to the other services. So, the GraphQL API calls the user service, or calls the course catalog service. And those spans have their own timing information and have maybe their own metadata that's being collected. And then you can even have, it's completely nested. So, you could have that service then, maybe it makes a call to a database or something like that. And so you could have a child span underneath, underneath the, so 2 levels deep here, and we've got timing information for how long it took to do a SQL query or something like that.
Right.
So,
okay. So what about sort of aggregating upward? One of the things that I've seen is a need to identify errors or, let's say, latencies associated with a particular user login session. So is there a way to sort of aggregate that up, multiple user calls for the same user into a session concept?
Right. So we used to get this all the time. My last company, Hobson's, we were kind of a software as a service company, and you get support tickets, and I'm sure a lot of people have probably had this, where a user is complaining that X is slow.
It's all driven by the help desk.
Right.
Yeah.
Yes. And so you might have some sort of what's that user's ID, or what's that user's login, or what was their session kind of thing. Or this might even start not from like a help desk. It might start from like a logs, right? So you get error logs, and the error log has information about, you're logging information about what session this error happened in or something like that. And so with Zipkin, you can you're kind of free to record whatever kind of metadata you want with each call, with each span. You can kind of associate whatever sort of, they call them annotations, which are basically just key value pairs. So it's, you can kind of associate whatever data you want. So you could absolutely record a user ID key value pair as part of your trace data, or a session ID key value pair, or and it really actually varies kind of based on what it is you're tracing. So you can imagine for an HTTP call, we might record not just the timing information, but also what was the status code that came back. Was it a 200? Was it a 500? Was it a 404?
Right.
That kind of thing.
So are we using like header request and response headers for transmitting these? So I don't have to add like this arbitrary tracing ID parameter to every method on my interface.
Yeah. So that's actually conceptually, that's Zipkin defines sort of these sort of well-known header names that are like X dash whatever, that are for propagating, at least with HTTP calls. This is how is how you propagate. This is how you propagate the tracing ID to child services and so on and so forth. Yep.
Okay, so you're getting all of this tracing data, and you're able to correlate it. Once presumably you're able to look it up and find it somewhere. So we've skipped the part where we talked about where you put all of this tracing data. Can you talk about that?
Yeah. So Zipkin, funny enough, I guess, supports Cassandra, right? So in our in our case, what we're doing is we're going to be storing this data directly in our DMC, our DataStax Managed Cloud cluster. So we'll have DataStax Enterprise cluster that's going to store this tracing data, and it when it inserts data into Cassandra, it has like a default TTL on it. So it's gonna you're not gonna be keeping data around forever. And they have some other storage formats I think that they support out of the box. I can't remember off the top of my head right now what those other storage mechanisms are that they support, but they do support some other ones. And then it also comes with sort of a UI then for drilling down into that tracing data. So they've got this pretty simple little UI for going in and finding, for example, the most recent traces, and you can kind of look and you get a visual representation of the spans, or you could find, you can go in and sort of sort them by what are the longest traces.
Yes.
So maybe you're trying to
find those long latencies.
Right, trying to find really bad latencies where people had a bad time on your website. That can be super helpful. So you kind of get this out of the box. You also get this UI for sort of drilling down into what's going on.
Okay, good. So I'm pretty confident based on what you have explained to me that you have the services tier and even kind of that GraphQL API layer pretty well instrumented at this point. But I mean, let's take this all the way end to end. Like, can you take this all the way out to the client, and can you take it all the way down to the database?
Yes. So you absolutely can. So right now, the way the project stands right now, I have not instrumented our client, like our React components. So basically traces right now in our current project, they start at the server. So once it hits the GraphQL API, that's when we start doing tracing data. But it's absolutely possible to essentially start with a tracing ID on the client side. And Zipkin comes with libraries for working with JavaScript, for example, if you're doing JavaScript front end kind of development, that make it pretty easy to do that. I actually did, so as far as going all the way down to the database tier, obviously we're using DSE as our storage for these services.
Right.
And so what I ended up doing, because clearly there's no at this point sort of out of the box DSE instrumentation, is I did a little bit of client instrumentation, which is basically just a wrapping of the Node.js driver for DSE. So kind of a proxy sort of thing that intercepts calls to execute and batch calls on made to DSE, and it kind of records some specific things like for example, what is the CQL query that I'm running, kind of information. So that's part of that custom metadata that we can record in Zipkin. We can record whatever we want, and so I'm wrapping the Node.js driver and basically kind of did this instrumentation sort of manually. It might actually be a cool open source project at some point. Like maybe I can release it as kind of a public thing on GitHub if people are interested in seeing how that was done. But so another thing though is in Cassandra, I think it was Cassandra 3.4, tracing became pluggable on the actual server side. So in DSE and Cassandra, you can actually plug in your own implementation of kind of what to do when you're tracing calls, because if you've ever you can turn tracing on and off. I don't know if anybody's ever tried this in the driver, but you can turn tracing on and off in the DSE drivers in pretty much all across all our languages that we support, and you get all this sort of rich kind of information. You can see it in Studio, for example. Like if you're ever using DataStax Studio and you go to do a CQL query, you can turn tracing on, and you'll get this sort of kind of almost like a query plan, like from SQL land, where you kind of see like how many tombstones it read, and where how many tables it had to hit, or how many tables on disk it had to hit, and blah blah blah. And
am I right to say that it's leveraging kind of a feature of maybe a lesser known feature of CQL, which is metadata that can be applied to messages that are going across. So.
Right. Yep. And so you can surface this information. So one option I would have would be to sort of like turn tracing on for some queries, like on my client side, like turn tracing on and then use, sort of take that tracing info that the driver sort of surfaces and try to put that data into Zipkin, kind of record it as annotations. But another option you have, because the server side is pluggable as of Cassandra 3.4, is you can actually just plug that in on the server side and have Cassandra, whenever it does a trace, or DSE, whenever it does a trace, actually send that data to Zipkin. So it can sort of participate just like any of your microservices servers would participate in tracing.
Right.
And so right now there's actually, there's a plugin out there. The Last Pickle guys did a cool plugin for doing that with open source Cassandra. I haven't tried it yet to see if it works with DSE, but that's definitely on my roadmap of somewhere down the road, trying to figure out, okay, how do we do this with DSE, and can we make this work in a DataStax managed cloud environment kind of thing. So I think that would be cool to have the server kind of do it for me instead of having to write code myself.
Right. So there is a little bit of trade-off here about what you get for free from using Zipkin as a framework versus what additional instrumentation code you might desire to write on top of that. Can you talk a little bit about where that dividing line and how you think about that?
Yeah, so Zipkin has a lot of plugins, so for example, we're in Node.js, so there are packages on NPM, the sort of the package manager for Node, and the package registry for Node, that are plugins that will wrap some really popular libraries that people might use in a microservices architecture. So for example, the fetch library, which a lot of people use for doing HTTP calls, just sort of plain old HTTP calls, like if you were calling a REST service, for example. They have instrumentation that is available already as a package that'll wrap fetch for you. Express is a really popular package in Node.js for doing servers, HTTP servers, web servers. So if you've got an Express server, they have plugins that will sort of do that out of the box. You don't have to write your own instrumentation code. But I did, end up having to write a fair amount, like for stuff that wasn't common, like out there yet. So like Cassandra DSE kind of stuff, I had to write some of that.
Okay.
So funny story. It's kind of almost an aside, but so we were using gRPC. So we had GraphQL API server that fanned out to our microservices on the back. And for the
Right.
microservices, and this is actually, if anybody has ever gone and looked at Killer Video, this is a very similar architecture to what we used in Killer Video. We were using gRPC to talk to the backend services. So the backend services were gRPC. So if anyone's listening out there and they don't know what gRPC is, this is an RPC framework from Google. And you kind of define your services in protocol buffers format. So you write, protocol buffers is the interface definition language. And then you can take those protocol buffers files and compile them to 8 or 10 different supported languages and sort of have typed clients with, request and response objects that are typed. And, if you're in a strongly typed language like C# or Java. And so you get a lot of kind of cool stuff. And then one of the other cool things that it has is it offers a built-in HTTP2 transport. So HTTP2 being the new version that's just kind of starting to see adoption in various browsers and whatnot. So it comes with a transport built in for all of the languages that it supports, where, when on my GraphQL server, when I go to make a call via gRPC to one of the backend gRPC services, it uses HTTP2 as the transport. And so, we're like, yeah, all right, this is exactly like Killer Video. This is really cool. And we're going to be deploying this to AWS. And so I'm thinking, well, we'll just use, I kind of did a cursory reading of I made the classic mistake of doing a cursory reading of the AWS docs for their application load balancers. And it says, yeah, we support HTTP2. And I'm like, great, I can just, I'll be able to load balance my gRPC services and whatnot. And
yeah. But I feel the but coming.
Yeah, and then but. And so, well, come to find out that what Amazon's load balancers actually do right now is they take HTTP2 traffic and then they sort of terminate it at the load balancer. Mm-hmm. And then when it actually goes to your backend service, it's actually HTTP1 traffic. They actually turn it into HTTP1 traffic, which would totally break the HTTP2 transport that we had that gRPC uses. So so basically, we couldn't use Amazon's load balancers with our gRPC services sort of out of the box.
Okay, so implications of all this for distributed tracing.
So implication is, we had to figure out, all right, what do we do? What do we do? Do we just rip out the H2 transport and replace it with something else, or so that we can still use the Amazon load balancers? Or do we do something else, like some other way of load balancing and communication between services? And so I spent a little bit of time actually looking at Envoy from Lyft. So, and I know you and I have actually talked about this. It's the sort of service mesh idea where Lyft is sort of runs, Envoy runs as sort of a sidecar and acts as a proxy to all of your services. So it runs as a sidecar next to your services, and anytime you need to make a service call, you
takes care of all your out of process interactions.
Yep, and it runs, like if I need to make a service call to another service, I can just call localhost where the sidecar is running, and then it figures out, because it's got built-in service discovery and routing capabilities and load balancing and stuff, it can figure out then where to actually send that traffic to, and so I was looking at that because they actually support HTTP2, so I wouldn't have to rip out the gRPC. But one of the cool things actually that Envoy also offers is sort of like a plugin is they actually offer built-in support for tracing, so for distributed tracing. And so any call that I basically would make through Envoy could automatically get recorded and pushed into, I think they support Zipkin right now as a tracing provider. So so you kind of almost get this like out of the box kind of black box level of tracing where all your HTTP calls, HTTP1 and 2 are getting traced at least at a low level. You're actually going to be able to see the timing spans, and I'm guessing they record HTTP status of the responses and that sort of thing. You kind of get it out of the box with something like Envoy, which is pretty cool. Like, it's pretty cool sort of base level of tracing that you could get. Now, that would be cool to do somewhere down the road. I think that would
and then we can do our service mesh episode.
Yes, we could do a service mesh episode. But I'm not ready. I wasn't ready to commit because I am a small engineering team of one right now, kind of working on this. So, I wasn't ready to commit to also having to run something else that I wasn't super familiar with yet in production. But it's pretty cool, like, sort of the base level you can get. Now, of course, you're still going to always want to do some sort of higher level, like, what you did at your previous job when you were working with hotels is not going to be the same sort of application or domain that I'm working in when I'm working on user progress and who's making progress on courses and units. And so you're still going to want to write instrumentation.
There's
code.
instrumentation specific to your domain that you're going to want to have.
Exactly. So you're still going to always kind of want to do this white box type of, you might get this black box stuff kind of like tracing out of something like Envoy, out of the box, which is actually a really great base to start from, but you're still always going to want to do your domain specific stuff, at a higher level. So
nice. Well, I think that at this point we've piqued everyone's interest enough that now they want to go do this themselves. Where should they go to learn about distributed tracing?
So there's two places. One that I didn't really mention, there's an initiative called Open Tracing that is basically a vendor-neutral standard for doing distributed tracing, and that's
which is a cloud native.
It's a cloud native foundation project. Yep, and it's at I think they're at opentracing.io, and one of the tracers that they actually support as far as implementation wise. So, it's sort of Open Tracing is sort of the API, describing the API of how we do this in a vendor neutral way that everybody can agree on. And then there's a bunch of tracers then that are actually supported, one of which is Zipkin. So if you want to find out more about Zipkin, I think their website is zipkin.io. So you can go and check that out as well.
Excellent. Well, thank you, Luke, for this guided tour that you have offered to us about distributed tracing. This is a really interesting area, I think, for helping developers in distributed systems be able to grasp what is going on, how to solve some of the hard problems, how to track down those long tail latencies. It's a real enabler for that.
Yep, that's a very big deal.
So one more advertisement before we go. If you will happen to be at the Strata Data Conference in New York City here in late September, we will have a DataStax presence there, and I will be there along with Patrick McFadden and David Gilardi. Sebastian Estevez, who's been a guest on the show, I think will also be hanging out. So there will be a good variety of characters there, and we'd love to meet you if you want to come and see us at the DataStax booth at Strata. Thanks a lot, and we'll see you next time.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.